There was a project in Alaska that I worked on. I got called up. The roof was essentially being torn off the tops of the walls. So it's this big rectangular building. You've got in this area, there's about 100-degree temperature swing over the year. Anytime you get that big of a temperature swing, stuff is going to move. It's going to expand and contract. As the temperatures drop below freezing, the roof membrane shrunk. And as it shrunk, it became like a big rubber band, and it just pulled the coping, the tops of the walls off of the building. And they couldn't figure out what's going on. It was structurally sound. We designed it to withstand this crazy amount of uplift, but it couldn't withstand the amount of pressure that was being put on it by this roof membrane. I looked into the manufacturer's data, and the manufacturer was involved with the design. They were there every step of the way saying, use these parts, do it this way, it'll hold up. But nobody had found, it's called the modulus of elasticity. They didn't bother to look at what the expansion and contraction rate of the membrane was that they were putting on. And when that temperature dropped, it just shrunk up so much, it started ripping the building apart. So that's something that they kind of, just to kind of go back to, they did the right thing. They brought the manufacturer in and said, hey, we're doing this. Is this okay? The manufacturer said yes. Then they came out later and said, well, you should have read our materials and known that it was going to shrink that much. No good deed goes unpunished sometimes, but the problem was solved eventually.
Right.